Welcome to Triumf, Canada's Particle Accelerator Centre. As we walk through the facility, you can pause the video and look around the 360-degree views of the video. The buildings on the left are our Isotope Separator and Accelerator, or ISAC, facilities. We are now coming up on the Advanced Rare Isotope Laboratory, or ARIEL building. ARIEL will be Triumph's flagship facility to expand Canada's capability to produce and study isotopes for physics and medicine. On our right is our main office building. Here you can find the director and senior management team's offices, as well as our finance and buyer's offices. The public reception area, cafeteria, and a number of other offices can also be found here. The main accelerator facility are behind a security fence. Access to this area is through the badge room. An access card is required to enter this room. Staff dosimeters are stored here, and as staff enter, they pick up their badges and continue through a second access door into the secured area of Triumf. On our right is our main accelerator building. This houses our main accelerator, a 520 MeV cyclotron. It is 2 stories below ground level behind the earth berm to the right. On our left is the ARIEL building, remote handling building, and the ISAC-1 building. As we walk down the road, we are passing over 3 tunnels. These tunnels link the main accelerator building with the ARIEL facility, the remote handling building, and the ISAC facility. 2 of the tunnels contain beam transport lines that deliver beam to the ARIEL and ISAC target hulls. The 3rd tunnel allows remote handling equipment to be brought into the cyclotron vault during service intervals. We are now heading into Triumph's Maison Experimental Hall. We are now entering the Maison Experimental Hall. The 520 MeV cyclotron is under the concrete shielding to the right. One of our newest facilities, still under construction, is the Ultra-Cold Neutron Facility, or UCN. It is a collaboration between Canada, Japan, and the United States. Its goal is to provide the world's highest density of ultra-cold neutrons. We are walking past our helium recovery plant. We recycle as much of our helium and reliquefy it, as helium is a non-renewable resource. The next beamline we see is M20. It is part of the Center for Molecular and Materials Science, CMMS. The CMMS uses Triumph subatomic particles as probes of materials structures. Ahead is our Thermal Neutron Facility, or TNF. This provides an experimental area for neutron irradiations. We are on the south side of the Maison Experimental Hall. Behind us is the IPF facility used to produce actinium-225. The yellow blocks below us are part of the 5,000 tons of concrete and steel shielding that formed radiation shielding over beamline 1A, its 2 targets, and the secondary beamlines that come off of the targets. On our left are some of the magnet power supplies, vacuum and target controls, and diagnostics controls. On the right is our proton irradiation facility. This facility is used by our commercial customers for electronics testing, as well as experimental medical research. On the left and up the stairs is the top of the solid target facility that produces rubidium for BWXT. Straight ahead, there are large lifting beams and other rigging equipment used to move the shielding and other heavy equipment with our 2 56-ton overhead cranes. The TR-13, Triumph's smallest cyclotron, has played a central role in the development of the University of British Columbia's world-class Positron Emission Topography, or PET, clinical research program, and in the development of BC Cancer's use of medical isotopes in clinical programs. The clean room to our right is used to assemble and align our clean beamlines components. On the left is the Maison Hall remote handling hot and warm cells used to service the Beamline 1A targets and active equipment. We are now on the south side of the main accelerator building. We are walking past the building site of the new Institute for Advanced Medical Isotopes, also known as IAMI. IAMI will be a state-of-the-art facility for research into the next generation life-saving medical isotopes and radiopharmaceuticals. It will comprise an integrated series of labs and a TR-24 medical cyclotron, one of the most technologically advanced commercial cyclotrons in the world. The TR-24 cyclotron, as well as our TR-13 and two TR-30 cyclotrons, were built by Advanced Cyclotron Systems in Richmond, BC. ACSI was created to commercialize a Triumph designed or TR series compact medical cyclotron. IAMI, when completed, will significantly increase British Columbia's and Canada's capacity for sustainable and reliable production of medical isotopes currently critical for Canadian health research and clinical use. As we continue to walk along, you will see two large transformers on our right. One powers the RF system, and the other the main magnet for our 520 MeV cyclotron. We are now walking under the ion source and beamline for the main cyclotron. As we turn to the left, we are passing the two main cooling towers, one old and one new. On the right is the E-Linac helium compressor building. This houses the main and recovery compressors, as well as the subatmospheric pumps that allow us to use liquid helium to cool the E-Linac cryomodules to approximately 1.4 degrees Kelvin. On the left is our electronics lab. Here we build and program our controls for the accelerators, beam transport lines, and experiments. Our electronics technicians also manufacture our specialized cabling for the site. Farther along is our machine shop. We manufacture our own equipment using CNC machines, water jet cutters, specialized welding equipment, and other tools. Having our own machine shop allows us to produce highly specialized and one-of-a-kind equipment for our facility and the experimenters. Triumph stores and shipping and receiving share the ground floor of the building to the left. Our engineering and design offices are housed upstairs. We use SolidWorks modeling to design our new components that are then produced in our machine shop. On the right is one of our many bicycle racks found around the site. Many of our staff ride back and forth to work year-round. The plant services building to the left has workspace for our millwrights, electricians, plumbers, and pipe fitters. Vacuum Group also has their workspace on the north end of this building. The main office building, straight ahead, have offices for strategic communications downstairs and Triumph Innovations, our commercialization company, upstairs. The plastics and scintillator machine shop shares the bottom floor of the main office building. We are now in the upper vault of the 520 MeV cyclotron. We started at beamline 1, which goes into the Maison Hall. The stairs to the right allow access to the top of the cyclotron. There are 12 jack stations around the cyclotron that allow us to lift the top half of the cyclotron to service equipment inside the cyclotron. We are walking towards the new Beamline 4 North beamline. This will provide a proton beam into the new aerial target hall. Once we turn the corner, you will see a tunnel to the left. This goes into the remote handling building. A service bridge is brought down this tunnel to service equipment in the cyclotron tank remotely. Ahead is Beamline 2A. It provides a proton beam into the ISAC target facility. The stairs to the right allow access into the cyclotron tank when the lid is up for servicing. You now get a view very few people get to see. We are inside the 520 MeV cyclotron tank. The lid of the tank has been raised to allow servicing of the equipment inside the cyclotron. As you can see the hunched over technician, this is not the most fun place to work.